Boys and girls, this is lesson 12.4, using similar triangles, and it is page 552 in your textbook. So the key idea here, angles of similar triangles. So remember that when two triangles are similar, they're the same shape, and I don't just mean triangles, but the exact same shape. That means their three angles of this triangle are congruent to the three angles of this triangle. They're the same shape, but not necessarily the same size. Okay, so the fact that these are different sizes, no big deal, but the angles are the same. And also remember that when we have similar figures, that the corresponding sides are proportional, and we'll have to get to that in a minute. But first, let's make sure that we understand how to identify similar triangles. So here it says when two angles in one triangle are congruent to two angles in another triangle, the third angles are also congruent and the triangles are similar. So for instance, if we have a 95 degrees and a 65 degrees here, and a 95 degrees and a 65 degrees here, these third angles have to be congruent, since these have to have a sum of 180, and these have to have a sum of 180. They both had to be 20 degrees, since these two were congruent. Well, let's look at the example down here. Tell whether the triangles are similar and explain. So here we have a 75, a 50, and a variable x. Here we have a 75 and a 50 and a different variable y. And we're supposed to tell whether they're similar or not. Well, this has a 75 and 50. This has a 75 and 50. So we could calculate to find out what x has to be. Has to add up to 180, so this would be 55. This also has to be 55 because these also have to add up to 180. So yes, they are similar, and our reasoning is the two triangles have two pair of congruent angles. That's all we have to say. For B, we have 54, 63, and x. And here we have 63, 63, and y. Now that doesn't necessarily mean these are not similar. We have to find out what x is, because this x could be a match to one of those 63s, and therefore the y would be matched to the 54. But let's just look at this triangle first. We have a 54, a 63, and an x. Here's what they have right here. We know that equals 180. So we solve for x. X equals 63. So this would be 63, 63, and 54. So yes, the two 63s match these two 63s, and these are two similar triangles. Incidentally, the y would have to match the 54 degrees, just so you know. So the triangles have two pair of congruent angles. Example 1c, same kind of problem. We have a 90-degree angle, an x, and a 42. Here we have a 90, a 38, and a y. So the 42 and 38 don't match, but we're not necessarily saying these are not similar yet. So we have to figure out what this x equals. X plus 90 plus 42 equals 180. X equals 48. It does not match this other angle, so the two triangles do not have two pair of congruent angles. This would be 90, 42, 48. This would be 90, 38, 52. So not congruent, not similar. They're both right angles, but they're not similar triangles because all the angles have to be congruent. The fact that they're both right triangles does not make them similar. So no. Well, now we're going to, on our own, tell whether the triangles are similar and explain. So we have two triangles here. This one has 28, 80, and x. So we know for number one that 28 plus 80 plus x has to equal 180. And that's 108 plus x equals 180. X equals 72. So now we go back over here. We know this is a 72. We have a 28, so one match. A 72 and a 71, an 80. So no, we do not have two angles that are congruent. So this is not similar. And because two angles are not congruent. Number 2, we have a 66, an x, and a 90. Well, so 66 plus x plus 90 has to equal 180. Combine our two like terms. We have x plus 156 equals 180. Subtract 156 from both sides, and x equals 24. So that is a 24. So we have 90 that matches, and our x is 24, and that matches this 24. So this is yes, similar. Two angles are congruent. So those are pretty simple problems. The next part says indirect measurements. Indirect measurement uses similar figures to find a missing measure when it is difficult to find directly. And remember that when we have similar figures, that corresponding side lengths are proportional. So here we have this kid, and I'll try to zoom in on that. We have this kid right here. He wants to know how far it is across this river. He probably wants to maybe make a jump for it or maybe swim it or something. But he wants to know how far that is. And so what he does is he marks this out on this side of the river so he can use the fact that these are two similar triangles to find this length right here. Okay, so he marches along here in a straight line, and then he makes a 90-degree turn, and he marches along here. This is just, he's not marching that because he'd have to march across the water. Then he comes here and he goes 90 degrees straight across here. Well, so he's got two congruent angles. Obviously, the 90 degrees are congruent. And then right here, these are vertical angles. And because they're vertical, they're congruent. So we have two, I don't know what the measurement is here. I don't know what the measurements are for these, but I do know these are congruent, and I know the two 90s are congruent. Therefore, these are similar triangles. Because they're similar, corresponding side lengths are proportional. So I like to go to the smaller figure, and I'll put those two measurements on top. I have a 40 and this x that I'm concerned about. And now I have got to, these are corresponding side lengths, so I'll have to do a 180-degree turn here and get this over here so that the 90 degrees match up. This 40 will flop down and correspond to this 50, so the 50 goes under here. And the x will go all the way over here and correspond to the 60. And now I can use my cross products to figure this one out, or I could simplify this, make this 4 over 5 equals x over 60, multiply by 12, x equals 48, and these are feet, so 48 feet. So yes, he could obviously easily jump 48 feet. I mean, I know I could. I'm assuming he could as well. And let's see what they came up with. Oh, good, they came up with 48 as well. It says, what if the distance from vertex A to vertex B is 55 feet? What is the distance across the river? So all they changed from this original was this distance right here. They made it 55. So now we would have 40 over 50 still equals x, but now over 55. This is for number 1 they want us to solve. We'll simplify this again to get 4 over 5 equals x over 55. Multiply by 11 this time, multiply by 11, and now that equals 44 feet. Let's look at a couple more examples of problems like that. Well, number 11, this is on page 555 in your textbook, is kind of an interesting problem. It almost looks like they don't give us enough information here, but they actually do. We'll have to figure out what these angles are. Well, first, we have a triangle here with 2 of the angles. We can figure out that third angle. Let's do that first. We know that the 90 degrees plus 51 plus whatever that is, we'll call it x, has to equal 180. Combine like terms to get 141 plus x equals 180. And now we know, subtract 141 from each side. X has to equal 39. Well, we also know that this is going to equal 180. So we know this is 39. Now 39 plus 102 plus something equals 180. So we'll write that down. So we have 39 plus 102 plus something. I'm not going to use X again because we already used X for this one. I'll use Y equals 180 because it's a straight line. And we'll combine like terms to get 141 plus Y equals 180. Subtract 141 from each side and get Y equals 39. Well, now that we know these both have right angles and they both have 39-degree angles, this obviously has to equal the 51, but even without even thinking about that, because they have two congruent angles, these are similar triangles, so yes. But now let's look at a problem like that river problem on the previous page. Here's a map. Shows the number of steps you must take to get to the treasure. However, the map is old and the last dimension is unreadable. Explain why the triangles are similar. So first let's explain why they're similar. Well, they're both right triangles, so they both contain a right angle, and they have these vertical angles, which are obviously automatically congruent. So whatever that angle is, it's congruent to this angle, and the 90s are congruent. So they each have two angles that are congruent. That by default makes the third angle congruent and them similar triangles. So now we can use the fact that similar figures, their corresponding side lengths will be proportional. Again, I do like to put the smaller lengths on top, so we'll do that. We have 80, and we have this amount that we don't know, and I'm not going to call it X because X marks the spot on this map right here. I'll call it Z. And now that 80, when I flip this around and put that right angle on that right angle, pivot it around this point right here, that 80 corresponds to 240. And my Z is going to correspond to 300. So now I could do cross products, but I'm going to simplify this first. 80 and 240, well, 80 goes in both those. But in case I didn't see that, let's simplify them by 10 first. And now we can divide by 8. Multiply by 100, multiply by 100. Z equals 100 steps. 100 steps. Okay? And then there is another problem down here. A person who is 6 feet tall casts a 3-foot shadow. A nearby pine tree casts a 15-foot long shadow. What is the height H of the pine tree? Well, they're both hopefully standing straight up, so they're going to have 90-degree angles to the ground. And since they're getting shadow cast from the sun, it's going to be the same angle. That's why it has to be a nearby pine tree, not a pine tree like on the other side of the world. Well, obviously that'd be dark at that point, but somewhere in a different state or something like that, because it would have a different angle to the sun. But since it's nearby, the angle from the sun will be the same. So they have similar triangles, so corresponding lengths will be proportional. So let's go, we'll assume that this person's smaller than the tree. We'll put their lengths on top. This is for number 15. 6 feet, 3 feet. So 6 feet is the person actual, and the 3 feet is the shadow. And then the corresponding measurements for the tree, 15-foot long shadow. So we'll put that with the shadow here, 15-foot shadow. And we're looking for how long is the actual tree. So I'll just use a T for that one for tree. Looking here, we multiplied by 2, so we multiply by 2, and the tree is 30 feet. Excellent. Well, you can work through some of the odd problems on this page, 555, and the odd problems on the previous page, 554. Make sure you're getting those problems right. If you don't get them right, or if you have any questions about them, throw them up in the comment section. And you can also get doing the homework, which will be posted momentarily. Have a great night. And actually, I did learn a new trick, so watch the little video clip at the end of this video.